Over the last couple of years, we've been building a 500-mile-an-hour jet-powered model aircraft called Kingfisher as part of our attempt to break the Guinness World Record for the fastest jet-powered model aircraft. Today, Kingfisher finally takes to the skies for the first time. In September 2024, we kicked off our flight campaign with our Kinglet subscale prototype, powered by an electric ducted fan. We used this as a testbed for refining every aspect of the Kingfisher's design, using a modular 3D printed structure for rapid iteration. We successfully demonstrated our catapult system in January, following a series of crashes as we ironed out our aerodynamics and tuned our flight controller. But better to learn these things at the subscale. It's actually in better condition than we thought. Really happy. Finally, in April, we landed Kinglet for the first time. It is in one piece.
It's in all pieces. It's immaculate, actually.
By the summer, we'd reached a design that we were happy with. So we transferred all of our knowledge into our full-scale Kingfisher Mk2 aircraft. This crams a 150 Newton jet engine into an airframe that is less than 1 metre long, albeit we're using a smaller 60 Newton engine for our maiden flight. A modular 3D printed design with internal aluminium skeleton was chosen for upgradability, while an instrumented avionics suite provides flight data. We completed ground testing of Kingfisher's subsystems in December and set our sights on the maiden flight. The last month has been challenging, as we've resolved issues with our catapult system. Kingfisher's heavier weight and higher takeoff speed requires 6 times more elastic energy than Kinglet and 900 newtons of bungee force.
2, 3, go.
During tests with a dummy aircraft filled with sand, we were struggling to get the aircraft to stay in the cart. We tried several different designs, and finally, after 4 trips to the field, converged on a new cart with a lightweight aluminium chassis and 2 steel pins which protrude into the aircraft.
1, 2, 3, Lord!
Yes! For the maiden flight, we're not too fussed about drag, so I designed a camera mount that sits on the top of the inlet, enabling us to interrogate any issues we might have with our controls during the flight. Finally, in late Jan, we took to the field to risk our prized Kingfisher aircraft on the bungee and have our flight attempt. Let's unscrew that.
That's not going down. I can connect and I can just see if it's easy.
Are you able to put your film and pulling the carriage back from the Right, you ready? 3, 2, 1, launch! Yes! Holy shit! Right, you've been flying for about 45 seconds. Try a high power pass if you're comfortable.
One minute 20. 1 minute 40. That was it. You probably got to think about landing it, to be honest.
That is absolutely amazing. Thank you very much for flying that. That is really a really significant moment on the project. That is the first time we have flown a jet aircraft. The first time we've flown the full-size aircraft that's going to do the record attempt.
And the Peter survived, look.
Everything survived. It is
Yeah, look.
completely in one piece.
Got a bit of Tristan's mud up here, but there we go.
I mean, I know people have said we've taken a long time testing things, testing with the smaller aircraft several times, but the reason why we test like that is so that we have a moment like this where it lands in one piece. That is absolutely brilliant. Couldn't have gone better. Over the moon.
After 3 years of work designing back from when we were at university to finally flying and landing our first jet turbine aircraft, this is a huge moment for the team, massive lift, and can't wait to see where we go in the future.
So that's how much fuel is left.
That thing weighs a lot.
Okay, that's how much is left.
To be honest, that's probably as... How's the UAT? Because that's...
The UAT's completely full. Time to go to the pub. At last, after years of waiting, Kingfisher finally flew. That being said, the catapult launch was pretty sketchy. And going forward, we're going to use a off-the-shelf pneumatic catapult system as we move towards the record attempt and want a bit more reliability. The aircraft achieved a top speed of 205 miles an hour, despite having the smaller engine, a large blockage from the cameras on top, and the outside being covered in exposed seams and bolts. So we're confident we can reach our 500 mile an hour goal once we've added a larger engine and coated the aircraft in a sanded composite layer for a smooth surface finish.
Roll stability was much better than on Kinglet. This is because of the increased size and velocity, reducing the frequency of wing rock. And this gave the pilot good control in manual mode, and so we didn't switch to stabilised, and we will assess the tune in future flights. The flight time of 2 minutes is tight. One of the challenges of designing an aircraft with a big engine and a small airframe is there's not really any space for fuel. So to combat this, we're designing an umbilical system, so we can keep fueling the system at start-up and allowing us to take off with a full tank of fuel.
Thanks for watching this video. Stay tuned for future videos and don't forget to like and subscribe. Thanks for watching.